So, as mentioned, I lead the informatics team at Scion. This team really is about what we do with information and with data to drive decision making. And you've heard a lot of presentations over the last few days that actually have informatics input in the background. And we actually have quite a strong representation for the team. It's quite unusual for us at one of these conferences. But it's really always been about data. We don't build robotics, we don't build UAVs, but we use them as data collection platforms to be able to drive data and decision making. As Jonathan Dash mentioned yesterday, we're the team that get to play with a lot of cool toys, although I think Lindsay's team with the cyborg is starting to challenge that. But that's been really good. So we've invested in things like the UAV program, bioinformatics, high performance computing. One of the advantages of being the leader of that team is you get to kind of explore these new ideas. But one of the disadvantages is also that when you're flying the country's first commercial UAV valued at about $85,000 and it's going along nicely and then it crashes into the ground at 70 kilometers an hour, you get to make the uncomfortable phone call to your CEO to explain what happened. The only solace I will take in that is that when we were flying that craft at the time, it was operated by a human being, but it sounds like in the future it will be flown by a moth. So perhaps Lindsay, you should chat with Julian about that. So anyway, I'm currently the leader of the informatics team, but I changed roles in about 10 days and moved to Timberlands as their new digital manager. And the reason I mention that is because over the last 5 years as leader of this team, it's been a real privilege to be able to push these types of conferences in terms of the thinking. And I want to do that a little bit today because I think over the past we've spoken about the UAV program, we've spoken about data analytics, we've spoken about high performance computing, and all of those things you will have heard over the last 2 days are starting to come together. So what I want to do is just push you a little bit in terms of analytics, and then we can have some of the same robust discussions that we've had over the last few years on the field trip tomorrow. So this is what I mean when I'm talking about a sensor. So we're not talking about a passive sensor. I'm talking about a sensor that is essentially something that collects data. In some cases will process that data, but then it transmits that data. And these are some of the examples that are available today. Some of those you'll be familiar with, some of them you won't be. But essentially these are things that are actually available to you as a forester within New Zealand already. I want to take an example that's slightly a little bit left field. So can I ask how many of you think that you're a pretty good driver? Like, not quite racing quality? Oh, come on, you're all so modest. Seriously. Yeah, there are a few at the back. I drove with one of them last night. But Formula One has always been on the cutting edge of both technology but also on a racing side, okay? Now these machines, this is the 2018 Red Bull racing car. It's got about 300 sensors in it, okay, of the type that I've spoken about. And that's measuring everything from trim to pressures and engine and all that kind of stuff. But what's impressive is that all that data is being collected on the car and then it's being transmitted in real time across the planet. So some of that goes to their manufacturing division, some of it goes to the engine manufacturer, and then decisions are made in real time and then they're brought back into the pit lane because they're not allowed by the rules to go to the car yet. But there's this real-time information share across the planet about what's happening in that car. And then what happens is that you get things like this. So it's no longer just about what's happening on the track. It's all the data science and the infrastructure behind that and the real-time analytics that allows them to make very important decisions while racing, but also afterwards it allows them to post-process that information and influence the design of their car moving forward. It's best said by someone who's in the industry. I really like this quote. If you read the first part, it talks about that there is no gut feeling in the sport anymore, that collecting and analyzing data points is now crucial to their success. Now, who would have thought that driving a Formula One car was now based on data analytics rather than driver gut feel? Now, I want you to picture that for a second because it's very easy to brush over that. But for those of you that did put up your hands about being a good racing driver, imagine now that you are Lewis Hamilton, arguably one of the best racing drivers on the planet. And you're racing down in Brazil, you're in second place behind some guy in front of you, you're going hell for nothing to beat him. And your race director comes over the microphone and he says, "Hey Lewis, the data is telling us that you're a little bit hard on the brakes in the third corner. Can you just take it a little bit easy so that you don't cook the brakes?" And Lewis goes, "Well, yes, okay, I suppose I'll listen. The reality is that Lewis knows that the person who made that call is not the race engineer, race director on the side of the pit lane. It's some 17-year-old girl in South Korea who's got blue hair, who's sitting in front of her data computer with a Red Bull because she was up half the night playing League of Legends, okay? So this is the thing. It's not just about the fact that it's about the racing job. This is not just about the technology anymore. It's about a cultural shift as much as it is about actually technology. I want that to be really important, is that what you're seeing here is essentially the combining of two worlds, a data world and a traditional world that come together. This is the next part of that quote, is that the media gives the impression that artificial intelligence is the answer to everything. So many of you will have seen that, we're all going to be out of jobs and we're going to be driving around in driverless cars. It's really challenging to do some of this stuff. But where it does work is where you get a mix of the domain expertise as well as the data science expertise. And that's really something that we've built at Scion over the last 5 years. We have some really smart data scientists, and we have some world-leading remote sensing specialists and geneticists and fire protection people, or general forest protection people. But the merging of that world is where we're starting to get real advantages. That's where a lot of the really new and novel stuff is coming out. And that's important because that is as much about cultures as it is about technology, just to say that again. And you're seeing that in that quote. You need to be able to bring the best of two worlds together. So you may argue, well, what does Formula One have to do with forestry? Well, the reality is, and you would have seen from Rian's presentation and some of the other ones, most of this technology actually exists in what you're using today on the side of the hill, right? So this is not stuff that's out there and inaccessible. It is already available to you. Not only that, but Rian made the comment about the fact that if you wanted to do some of this stuff, you needed to be able to send the data to the cloud. Well, increasingly, that's actually a reality. So this is an example from Microsoft talking about their edge technology. An edge technology basically means that they take the cloud computing, and some of it is actually done by the sensor out in the field. And if that's not really good enough for you, if you Google Microsoft Edge and agriculture, you'll see that they're starting to put edge computing in the back of your ute. So you basically have a mobile cloud computing cluster in the back of your ute that can do all the data processing that you're needing to do. So this technology is becoming increasingly accessible in really hard to reach domains. Not only that, but we know that there is increasingly discussion across agriculture and forestry, particularly across Australasia, about data access out in the forest. And so we're seeing a lot of companies spending exorbitant amounts of money to make sure that your forest has data access. Now, some of you already have that, but increasingly that will roll out over the next 18 to 24 months. So this is really important to see that this stuff is, again, not far away. We're talking 12 months and you will have access to all of this. What's really important about the Microsoft example as well is that this is something that you use day to day. So you use Microsoft Word and Microsoft Excel. Some of you are using Office 365, and Azure Cloud Computing is just an extension of Office 365 in some ways. So these tools are really accessible, not just to big owners, but to farm foresters as well. So just talking about some of the real world applications, because this is all great, we're waving our arms about this wonderful technology. But there really are 4 key aspects that usually drive business growth and business efficiencies with these types of technologies. And I'm happy to give examples of some of these a bit later if you're interested. But one of the big ones is optimization, and often that's targeted in supply chain. So this is not just about tracing a log or a kiwi fruit through the value chain. It's about saying what kind of information is being collected about the environment that that log or kiwi fruit is sitting in. And how can I use that to better make decisions, and what are the data science things that we can do around that to drive better decision making. That might be about fulfillment, whether it's cut plans or orders to market, whatever it is, but a lot of really smart data science stuff that's coming in from the side. Targeting is an interesting one, and I'll pull out the employee one because we're not talking about headhunting people here. What we're saying is that how do you decide the person that's going to work in your company moving forward? And the argument is often, well, it's gut feel. We have an interview, we do some cultural checks. But what about the Formula One example where increasingly data is driving decisions? So what happens if you could link my LinkedIn profile as a new employee or someone who's applying to work, together with your company LinkedIn profile and the LinkedIn profiles of all your employees to really judge whether that person's going to be a good fit based on what they like, what they look at, and the types of connections that they had. So these types of technologies are becoming a lot more advanced with real-world applications. Prediction is another one, and quite a topical issue. We heard yesterday about some of the work that Ralph has done with NARI about being able to predict red needle cast. If you saw that diagram, I mean, that's a huge number of data sets and very complex information, and that's all pulled together to data science to get a fairly simple answer at the end of that. And most of that, if you have a look at the tool that Ralph demonstrated, it's in an easy to use interface. It's not hard to and inaccessible. So it's about the power of all the data analytics in the background that makes it easy to anyone to use. And then finally, in abnormalities, really looking at trends that a human may not be able to pick up looking at smaller data sets, but where a computer comes in and goes, well, actually, I'm not going to make the decision for you, but here's something that looks a little bit out of the ordinary. Or a data scientist can look at it and go, well, actually, there's a trend here that's a little bit unusual. So why don't you have a look at that and make a decision? Again, the domain science linking in with the data science. Just to talk specifically about some examples, agriculture is rolling out a lot of this in productivity and yield, particularly where, as Rian showed, there are the harvesters and machines out in particularly broadacre where the sensor is on the unit. So this is a case of where multiple sensors from across the US, for example, are collecting all this information. A company like Trimble or John Deere are amalgamating that information. Some decisions are being made, and then the best decision-making or optimal yield prediction or whatever it is being sent back down to the farmer. And so this kind of technology is being applied in real time. Local examples of that in New Zealand are things like your irrigators, which are now automated, or automated milking that's coming in. Logistics support, best example of that is Qantas Airlines that did some work with the University of Sydney, where they looked at the routes between Sydney and I think it was Singapore over the last 10 years. And they took flight data and linked that with weather data and came up with the best predictive models. And so now when you fly on Qantas, although you really shouldn't fly with Qantas, but if you do fly with Qantas, then you can know that the aircraft is actually in real time using weather data together with this historical information to best predict the route that will give you the smoothest ride with the best fuel efficiency to get you there on time. Grain futures is another one. So again, if you're in that world at all, the ability to predict what that's going to happen has massive financial implications. And so they take things like social media information, they take some of the productivity information that, again, John Deere and Trimble are collecting, and they're using it to do predictive analytics. And the final one is an example from the agriculture in Australia, where they're linking sheep, so robotic meat production from sheep to be able to analyze the best cut for a sheep based on current market conditions, and then link that into real-time blockchain and into smart contracts so that the farmer gets paid the very best price when that sheep is cut up into the different segments. So all that kind of stuff is no longer in the future, it's actually happening in reality. Just finally, what is Scion doing in this space? So I mentioned the Lucy platform. The Lucy platform is a processing platform that we have around point cloud analytics. And so we've worked with some really smart people to be able to produce something that can do very high-speed data processing. This is something that we're hoping to roll out across the sector, whether you're a small forest owner or a big one, within the next 12 months. We're exploring data science for forestry, and what I mean by that is it's not just Scion doing that. So we're partnered with Microsoft. We've had discussions with a company called Myriad. We're working with, we've got interest from IBM to talk to us about artificial intelligence. In the working to get high-speed data access, we're working with companies like Spark and Cordia. So there are a whole bunch of technology companies that are going, anything to do with ag tech, and forestry is kind of seen as part of that, is really interesting for their businesses. So they're wanting to be able to kind of talk to us and make that system work. And so, yeah, there are a lot of partnerships happening. And then you get to play with some new cool technology, which we're exploring as well. Just to summarize at the end, so I'm reflecting on this presentation, and I guess the take-home message for me, if you look at the example of Formula One and some of the changes in that, and if you look at the example of what we've spoken about in agriculture, you reflect on the conversations we've had over the last couple of days about the wanting to get new people into our industry and the School of Forestry and all of these changes and the issues that we have around climate change and 1 in 100 events. There really is an opportunity here to use these kinds of new technologies to answer some of that. Not necessarily to make the decision for you, but to certainly help you make that decision. And a lot of this technology is actually quite accessible. The barrier to entry is actually pretty low. But it's going to take a cultural shift, not just from data science people wanting to work in forestry, but from foresters welcoming in people from another sector as well. And so I really challenge you to be thinking about that in your businesses and as you go about day to day, to really think about, well, what does this mean for me? What is the culture shift that I'm going to have to make? Maybe I need to learn something about this skill set in order to progress forward. Because we really don't have enough data scientists to do it in the planet, to fill all the jobs. Everyone is going to have to learn something about this if you're going to make the most advantage of this in your business. Thank you very much.